Our society produces a lot of waste, over 2 billion tons per year, in fact, a number that's expected to grow by 70% by 2050.
That's a line of garbage trucks stretching from San Francisco to New York City every single day.
Organic materials in landfills decompose, they produce methane, a very potent greenhouse gas.
Solid waste, plastics, paper, cardboard, there's a lot of energy within those, carbon and hydrogen.
Why don't you do something useful with it?
Converting waste into energy is not a new idea. Usually, though, this has meant incineration, that is, burning our trash to recover some energy. But that has major drawbacks. Incineration creates toxic ash and hazardous chemicals called dioxins, and heat and electricity are pretty much the only usable outputs. A better solution may lie in gasification, an old technology which has only recently been repurposed as a way to deal with our waste. Gasification companies don't burn trash. Instead, they turn it into a gas, in a process that they say is both economical and eco-friendly.
The focus is on producing a good quality syngas that can be converted into higher value energy products on the back end, be it electricity, hydrogen, diesel fuel, possibly even chemicals, fertilizer, etc. in the future.
It's an exciting idea, and some major players, including the Bill Gates-led fund Breakthrough Energy Ventures, have thrown their weight behind it. While in the past, gasification companies have struggled to scale up and meet their energy production targets, now companies like Sierra Energy, Enerchem, and Plasco say they're ready to commercialize and expand.
I think we have over 9,000 interested parties from around the world who've contacted us already. The question is, how quickly can we get one? The answer is soon.
The world's first municipal waste incinerator was built in 1874 in Nottingham, England. And like incinerators of today, it converted trash into ash, gas, and heat via combustion. Initially, the purpose was just to shrink our waste. Eventually, though, Great Britain and Germany did start recovering energy from the process, but the idea didn't really catch on in the US. Domestic electricity prices were already low, and as emission standards tightened, incineration got even more expensive as compared to landfilling. It wasn't until the oil embargo and resulting energy crisis in the 1970s that the US really took an interest in waste-to-energy tech. Over 100 waste-to-energy incineration plants were built, but when fuel prices dropped, interest waned.
You see a lot of interest on this waste conversion or biomass conversion when the fuel price is really expensive. And then when the fuel price drops, nobody really cares.
Today, there are about 70 waste-to-energy plants in the US, and the number is declining. But globally, many European countries still rely heavily on incineration, and Japan and China have been building waste-to-energy incinerators at a rapid clip. But many environmentalists say we need a better solution. Incinerators still emit harmful pollutants, especially in countries with lax environmental regulations.
So burning waste to get rid of it may appear to be cheap, but the long-term health consequences for the community is terrible.
So companies like Hart Sierra Energy are looking towards gasification, an old technology that proponents hope to repurpose as a cleaner and more economical waste-to-energy solution. In the gasification process, materials aren't combusted. No toxic ash or dioxins are produced. Instead, a highly controlled amount of oxygen or steam reacts with the waste, turning it into a gaseous mixture of carbon monoxide, hydrogen, and other elements. This synthetic gas has applications beyond electricity generation. It can be converted into high-value products like diesel fuel, hydrogen fuel, or ethanol. So even if electricity prices stay low, there'll be a market for these outputs.
We see much more value in chemicals and biofuels. Methanol is an important building block in the chemical industry. Ethanol is, of course, as you know, can be blended in fuels.
In this way, waste-to-energy gasification plants have both upstream and downstream revenue potential.
On one side, you're being paid to take garbage that normally would be dumped into a landfill. So that's one source of revenue. You then take that waste and you turn it into recycled products. Those products have very high value. And so from a business model perspective, you're getting paid on both ends.
But a main challenge facing companies like Sierra Energy, Enerchem, and Plasco is dealing with the unpredictability of using municipal solid waste as the fuel. Globally, there are hundreds of gasification plants that generate electricity from fossil fuels like coal, But waste-to-energy gasification is a whole different game.
Tailoring your gasification when your fuel changes over time is the holy grail. And if they can consistently gasify and produce their natural gas from these waste materials, even if the content changes, that's an exciting option.
Here are some of the main players taking that plunge. Davis, California-based Sierra Energy was founded in 2004. Back then, CEO Mike Hart, who is also the CEO of Sierra Railroad Company, was seeking to improve the fuel efficiency of his locomotive fleet.
We were trying to figure out a way to make our own fuel. We wanted to do something better than diesel.
He was judging a business competition at UC Davis when he heard about how blast furnaces, one of mankind's oldest technologies, could be used to convert any mixture of materials into a usable synthetic gas. Hart bought the patents to this technology, and Sierra Energy was born. Over time, its mission expanded far beyond its initial reach.
People are realizing that climate change is a very real problem. When you throw away 1 ton of garbage, every ton is about 6.2 tons of CO2 equivalent goes into the atmosphere in the form of methane. Methane is 86 times more potent a climate change gas than CO2 over a 20-year period. Our technology provides one way of trying to address that problem.
Last July, Sierra Energy closed its $33 million Series A funding round, led by Breakthrough Energy Ventures, the Bill Gates-led investor fund that also includes Mark Benioff, Jeff Bezos, and Richard Branson. Now, the company has partnered with the Department of Defense to develop its first small-scale commercial facility at Fort Hunter Liggett in Monterey County, California. This demo facility can handle 20 tons of waste per day, and if all goes according to plan, it will begin processing trash in early 2020. Ultimately, Sierra Energy says what sets them apart is their use of the blast furnace, a centuries-old technology in the iron and steel industry. Here's how it works.
A blast furnace, which is the technology platform that Sierra Energy uses, is a high-temperature vessel. Solid materials go in at the top, injectant gases are placed in at the bottom, and you have a big countercurrent heat exchanger. We're injecting oxygen and steam at the base instead of hot air. And at the top, we're placing in solid waste materials instead of those mined materials from the ground. And instead of the focus being producing good quality metal out the bottom, our focus is on making a good quality syngas synthesis gas out the top of the vessel.
Once the syngas is produced, the local community or developer will decide what to do with it. The company lists electricity, hydrogen, renewable diesel fuel, and ammonia as likely end products. About 10% of the waste material can't be converted to gas, and so is instead turned into a stone that can be used as construction material. Because of this wide variety of use cases, it's hard to say for sure exactly how clean the end-to-end process will be.
It really depends on the specifics of the project, how far waste is having to be brought to the location, some of the configuration of the plant itself.
Hart is confident, though, that in almost every case, it will be carbon negative.
Because even if you're making electricity or diesel for a vehicle, the amount of pollution that comes out of the tailpipe or smokestack is less than the amount of emissions that you're offsetting in the first place.
Furthermore, Sierra Energy's plant doesn't rely on external energy to operate. Instead, Hart says that about 20% of the energy created is used to run the plant itself.
And so by some people's analysis, you can make this carbon negative or carbon neutral. By other analysis, you can't quite get there, but it's certainly cleaner than fossil natural gas.
Over the next few years, Hart says the company plans to build out community-scale systems that can handle about 50 tons of waste per day, the equivalent of approximately 50,000 people's trash.
If we want to have an impact on that 13.2 billion tons a year of greenhouse gas, we need to have thousands of these systems around the world as quickly as possible. That's our goal as a company.
While Sierra Energy's most recent funding round has put it in the spotlight, there are a number of other veterans in this space. Two of the biggest are Plasco Conversion Technologies, founded in 2005, and Enerchem, founded in 2000. Like Sierra Energy, both aim to turn municipal solid waste into valuable end products through gasification. But unlike Sierra Energy, these two companies have actually accumulated years of firsthand experience operating full-scale gasification plants, dealing with their fair share of delays and setbacks along the way. Plasco Conversion Technologies uses plasma to refine the waste from gasification into a clean syngas. The company operated a large demonstration facility in Ottawa from January 2008 to January 2015, capable of accepting 135 tons of waste per day. Eventually, Plasco got approval to build a commercial-scale plant, and though the company raised over $300 million, it ultimately wasn't enough. The new plant was never built, the demo facility shut down, and Ottawa severed ties with the company. But Plasco kept chugging along and re-emerged with a new outlook on the market.
We put in 1.2 million man-hours and a decade of work and $407 million. We can tell you many ways it don't work, and what we do now does work. In the process, we realized that the waste to electricity market, the waste to energy market, was going away.
Unable to compete with the low price of natural gas, Plasco now aims to produce synthetic fuels for use in internal combustion engines, which can power cars, planes, and trains. The company no longer operates any plants, but it says there are a number of projects in the works. And for these future endeavors, Plasco has slimmed down its business model.
We aren't doing build, own, operate, transfer anymore. We're doing selling the equipment and the technology. So we restricted what we did so we weren't in competition with the entire world, but more in cooperation.
Another player, Enerchem, developed the world's first commercial waste-to-biofuels facility of its kind. It's been operating in Edmonton, Canada since 2014, and is currently focusing on turning trash into ethanol biofuel and chemicals like methanol.
It's a facility that can take up to 100,000 tons per year of waste, around 300 tons per day. So this type of size would represent a community of around 500,000 to 700,000 inhabitants.
This plant uses a technology called a fluidized bed gasifier, in which the trash is dropped into a bed of hot sand, oxygen, and steam. The precise mixture causes the waste to heat up and turn immediately into gas. But Enerchem has also faced challenges as it scaled up. The company initially predicted its first plant would operate at full capacity by 2012, but it still isn't there yet. The company won't reveal how close it is to full-scale operation, but Chornay says that despite the delays, he's glad that his company is taking the time to get it right.
We're really proud that we did not skip any steps. However, this comes at a cost. So we have both a patient approach and a realistic approach for innovations of this scale, and also we have an enormous database as well as operation time at commercial level. So these three aspects really differentiate us.
In its 20-year history, Enerchem has raised $616.5 million and now has plans to build additional facilities in the Netherlands, Spain, the UK, and Canada. It's one of the most well-established companies in the space, but with just one commercial facility, there's still plenty of room for others to play catch-up and learn from what's worked and what hasn't.
Everyone likes to be in the race to be number two. The idea is the first plant, the pilot plant's more expensive, so you'd rather learn from somebody else. On this topic, I'm not at all worried. The first one at large scale may have some kinks in it, but it's also likely to get some of the best subsidies and deals from the municipality.
These potential subsidies, alongside other policy drivers, stand to play a major role in determining how quickly this tech spreads.
So the future for gasifiers is, in my view, more tied to the economics of the climate change story, the prices on carbon, the prohibitions on emitting any fossil fuels, than it is on the technology, which we've known about for a long time.
Given current policies, such as California's low-carbon fuel standard, Sierra Energy says it could build many more plants, but not on the scale that they'd like to see eventually.
To get to hundreds is very feasible, but to get many thousands, that will need different regions of the world to step up and force people to divert waste from the landfill.
This could look like higher landfilling fees, carbon credits, carbon taxes, emissions regulations, or subsidies. Any and all would be a boon, so long as these gasification companies can operate as cleanly as they claim. But as climate policies and priorities shift in tandem with election cycles, it can be hard for this tech to establish a strong foothold.
Once we know, okay, this is the policy that we're going to stick with for 10 years, I think there will be a lot of confidence for these investors. But if you don't know what the policy is going to be, every 2 years or 3 years or 4 years, it's very difficult to make any decision.
But as our landfills fill up and the world gets hotter, companies, investors, and the public at large are realizing that we can't wait much longer to seek novel solutions.
People who say, we'll recycle our way out of it using conventional means, those people are out of their minds. It's not happening. If we're going to do anything to try to reduce climate change, those 13.2 billion tons of CO2 equivalent going into the atmosphere from landfills is the very first place that we should try to address it.